Okay, so this is lesson 9.2, special right triangles. I'm going to go over the 45, 45, 90 triangles first, and then we can switch over and do the 30, 60, 90. So this is kind of a little introduction here to where we get special right triangles and their patterns from. It's just a way to memorize a pattern for specific types of triangles. So a 45, 45, 90 is referring to the angles here. So it comes from doing Pythagorean in a square. So I'm going to go ahead and split this square into two triangles here by drawing my diagonal here. Alright, so when we're thinking about a square, we know we have four congruent sides. We also know we have four right angles. Okay, so the line that I drew the diagonal here acts as an angle bisector. Remember, square has both properties of a rhombus and a rectangle, so a rhombus would be where it's getting the angle bisector from. So if I split that in half, I know this is 90 down here, but if I split these in half, I end up with 45 degrees and 45 degrees. So that's where we're getting this 45, 45, 90. So the same thing happens over here. These are congruent triangles. So we end up with two 45, 45, 90 triangles. Okay, and they are also isosceles. I see that these are exactly the same length here. So I'm just going to give you some lengths here. Okay, so let's say this is 1, and this is 1. It could be feet or something like that, but I'm just going to leave it as 1. And we can figure out our hypotenuse by doing Pythagorean. I know across from my 90 is always the C, which would make this A and B. So I'm just going to redraw this down here. It's a very rough sketch, sorry. So here we have 1, 1, and C. So we know we're going to end up with these being congruent, even though they don't look congruent because I just quickly sketched that. So again, this is A and this is B. So if I plug this into Pythagorean, I can start simplifying here. So 1 squared and 1 squared is 1 plus 1, which is 2, and the last step here is to square root it. So C is equal to the square root of 2. Okay, so this is where we get our pattern from. So for every length here, if this length is 1, then that means this side over here, my hypotenuse, is going to be the square root of 2 times larger. Okay, so we multiply whatever value this is by the square root of 2. So again, this is just the background information. You don't actually have to do this part, but this is explaining how we get our pattern from. So I'm going to switch over to our foldable, which is your big piece of paper. You should get the one that says 45, 45, 90 in the middle. We're going to do those first. So I'm going to fold it in half widthwise. And then I'm going to fold it in half again, folding down. And that should create your little foldable there. Okay, so I'm just going to rewrite that rule. Maybe if I can get this straightened. Okay, so you can call it a rule, or I like to call it a pattern. This is another thing that we do have to memorize, though. It's not given to you on the EOC. Alright, so in a 45, 45, 90, again, these are going to be congruent, and we're just going to write those as x values. So those are going to be the sides that are across from the 45 degrees. So across from 45 is our x's. Okay, and then we already said across from this 90 degrees is our x square root of 2. So whatever number is here, we're going to plug in and multiply that by the square root of 2. It's the square root of 2 times longer. Okay, and the method that we use here to solve for these, which we'll do in a second, is called the Tic-Tac-Toe Method. So you're literally drawing a tic-tac-toe board. And I'm going to write my 45, 45, 90, and then I'm going to follow it with my pattern here. So across from my 45s are the x, and across from 90 is x square root of 2. Okay, and we'll do examples in a second where we would plug in values there, but that is just kind of our pattern and how we would solve. So grab your red sheet. I know we have a lot of papers going on, but we're just going to practice doing some of these before we actually jump in to the examples. We're just going to practice the math first. Alright, so I'm just going to give you some values here, 8, 7, 6. So if my x value were 8 here, again this is an isosceles triangle, so these two columns should look exactly the same. So we can just copy those in. And these are our easy examples when it's just a whole number, because I take that x value, whatever is in these columns, and I plug it in to the outside right here. So this would just become 8 square root of 2, 7 square root of 2, and 6 square root of 2. Okay, so I'll give you a second. You can pause the video here to fill out your answers. Okay, and there's your values for 4. I'm just going to draw a line here because this is our next type of answers that you'll get. So I'm going to give you the square root of 3, 5 square root of 7, and 2 square root of 5. So again, this column should look exactly the same. And now we're taking that value again, and these two columns are exactly the same, so use either one. I'm going to take that value and I'm going to plug it into the x, same as that we did up here. But remember that these numbers, whatever's on the outside, or that x value is being multiplied by the square root of 2. So we're really taking the square root of 3 and multiplying by the square root of 2 here. Okay, so this is where we have to remember how to multiply radicals. So if they're like terms, both on the inside, we can multiply together. So this ends up being the square root of 6. Okay, we're going to do the same thing here and multiply 5 square root of 7 times the square root of 2. The only like terms I have here are 7 and 2, the ones inside. So we're going to leave that 5 on the outside, and this becomes the square root of 14. So you can pause the video here and go ahead and try that last one. Okay, and here is our answer, 2 square root of 10 is what you should have gotten. Okay, and then the last type we're going to do, I drew another line there. You'll see a pattern with each chunk of these, how you would solve. So I will do one example and you can finish the rest here. So again, this column should look exactly the same. And then we're multiplying 3 square root of 2 times the square root of 2. Okay, we can work this out a short way or a long way. Maybe some of you remember what happens when we multiply a radical by itself. But if you don't, we can just solve it the long way. So our like terms are 2 and 2. So this becomes 3 square root of 4. But that is not my final answer because the square root of 4 is 2. So that becomes 3 times 2. Okay, that's the same, those are equivalent numbers, square root of 4 and 2. Those mean the same thing, and remember, we were multiplying here. So this ends up being a whole number, which is 6. Okay, so you'll see a pattern here. I'll actually do the next one as well. So the square root of 2 times the square root of 2 just became a 2. So you can kind of like bypass that step right there. So 7 square root of 2 times the square root of 2 is actually just 7 times 2, which is 14. Okay, so pause the video here and go ahead and finish those two. Okay, and there's my values. So that's just kind of a background before we jump into the actual, what am I trying to say? Oh, examples. So go back to your foldable. We're going to do some examples here. So I'm going to open it all the way up to example 1. So again, I always solve with the Tic-Tac-Toe method. I think it's just a very helpful method. The more you practice them, you might not need to use this method, but for the time being, we're going to use it. So hopefully you remember the pattern. It's also written right there, x square root of 2. So across from my 45s are x's, and then x square root of 2 goes there. Okay, so for this method, we first want to fill out all the angles here. If this one is 45, this one has to be 45 as well. Not because it's a 45, 45, 90, but I know that triangle sum tells me all three of those angles have to equal 180. Okay, we already have the 90, so really you're just doing 90 minus 45 to get that left over there. Okay, so that is where we're getting that from. And I'm given one side here, and I'm going to use that side to figure out my other ones. So I first want to figure out where it is across from. So I'm going to just kind of identify that side as 8, and I'm going to go straight across from that to the angle that it is that is opening up to that side, 8, and it is 45. So I'm just going to copy in underneath my 45s 8. Okay, and then of course if my x value is 8, I'm just plugging into the outside here, so that becomes 8 square root of 2. So to figure out which one would go with which, I again just use my columns here. Across from 45s are 8. I already have that one, and then I can go straight across and get my other one. And then I know my hypotenuse, or my side across from 90, if I just follow straight down, is going to be 8 square root of 2. So ED, which is the side here, would be 8, and DF would be 8 square root of 2. So this is our easy example here. Okay, so let's switch over to example number 2. This is another easy example, but here's where you are looking for your x values and given your x square root of 2. So this is also our easy example. So again, I'm going to do my tic-tac-toe here. X square root of 2. Sorry for the sniffing, I'm a little sick. Okay, and again, I just want to figure out what I'm given. So I'm going to underline that side, 5 square root of 15 square root of 2. Sorry. Okay, so again, we're just going to underline that 15 square root of 2, and I'm going to go straight across, and that is across from my 90 degrees. So I'm going to find 90 and plug it in there. Alright, these are easy when they match here, the square root of 2 and the square root of 2. That means my x value is just the number on the outside here. So x would just be 15 here. So no math required there. I know each of these NE and EW will end up being 15 because that's what I was solving for, but we can practice that again. Oops, I should have finished spelling out my angles here. So again, across from 45 and across from 45, I'm just going to copy down my x value, which is 15. So NE is 15 and EW is 15. So these are your solving for x, that x value here. And these were where you were solving for kind of both, but you were really just solving for the x squared root of 2. Okay. So go ahead and pause the video here and see if you can set up your tic-tac-toe chart for example 3. Okay, so here's your setup for your tic-tac-toe chart. I drew an arrow across from 45, or across from my side, to find that it was across from 45, so I just plugged it in under the 45s. Okay, so I'm really solving for my x square root of 2 here. So this is my x value, so again, back to this chart, we're plugging in that x value in front of the square root of 2. So we're really doing 7 square root of 2, that's my x value, times the square root of 2. Okay, and if you remember the shortcut, this is really 7 times 2, or just multiplying that. The square root of 2 times itself is just 2, it just kind of eliminates that radical sign, which is 14. So again, I just want to go back and plug in. So across from my other 45 is 7 square root of 2. Those are my congruent sides. And then across from 90, I follow it down, and that is 14. So AC is 14, and that one is 7 square root of 2. Okay, and same thing here, pause the video and try to set up for example 4. Okay, so here's our setup for example 4. We are given the 90, or we're given the x square root of 2. But the issue with this one, before they matched up perfectly, so I just got that outside number as my x. Here, I can't easily pick out my x value. I don't have a square root of 2. So there's kind of some different ways we can think about this. So these are equal values, like x is equal to 5, x square root of 2 is equal to 15 square root of 2. So we can really just set these values equal to each other anytime. So in this example, we're going to have to be solving for x. Oops, I messed up with my colors here. Okay, so we're kind of working backwards here. We're trying to figure out your x value using this number right here. So that's one way we can think about it. We can just set them equal and solve. So x square root of 2 is equal to 22. Okay, you're also just working backwards here. So I know x times the square root of 2 is 22. That means that I'm going to take that 22 and I'm going to divide by the square root of 2 to find that x value. So you can really do that with any of these as well. Just kind of work backwards and do 22 divided by the square root of 2. You'll see it in either way. I'll do that over here. We're going to end up with the same answer. So I'm dividing. Sorry about that. So here, these are being multiplied. So the opposite of multiplication is division. So really, we end up with that same equation anyways. So we were just kind of skipping a step here. But let's just continue on with this one. So this is as simplified as I can get it. These are not like terms, so I can't make it 11 over 1 or anything like that. But the reason this is not okay is because we have a radical or a square root on the denominator, which is not okay. Okay, so this is where we have to rationalize, which hopefully you remember. We're going to take this value, I'm just going to move it over here, and we're going to multiply by the denominator over the denominator. So in this case, we're multiplying the square root of 2 on both top and bottom. So remember, the whole point is to get that radical off the denominator, So the square root of 2 times the square root of 2 just gives me 2. I'm going to have to write this down here. 2 on the denominator, and then I'm going to multiply across here, and that is 22 square root of 2. Those are unlike terms, so we just kind of glue them together. Okay, and then the last step, we can simplify 22 over 2 to be 11 square root of 2. So kind of a long process there just to figure out your x values are 11 square root of 2. That means across from my 45s are both 11 square root of 2. But maybe you can see a little shortcut here. When this is a whole number, and I'll write that over here. When the number So the number across from 90 is a whole number. So for example, 22. For example, just i.e. For example, 22, you divide by 2 and put it next to the square root of 2, therefore 11 square root of 2. Okay, so all we did was do 22 divided by 2, we got 11, and then I know it's going to be a square root of 2 here. And that makes sense. If I multiplied 11 square root of 2 times the square root of 2, I would end up with 22. Okay, so that's a little bit more advanced there, and then these are kind of our difficult level ones, difficult level. So pause the video here and give these a try, and I'll put up the answer key. Oops. Okay, you can pause the video here and check your answers. So in the first one we were given our x value, the square root of 2, so I just plugged it in over here to get 2. And then for this one, we were given 90 and we had to work backwards and divide. You could have rationalized, but you can also do, again, 13 divided by 2, which is 6.5, and place it next to the square root of 5. So that is our shortcut. Okay, so not really difficult there. I will make another video for the 30, 60, 90, which you can watch, but this concludes our 45, 45, 90 lesson.